Hello, my name is Trinity Shuler, and today I will be talking to you about the information you can derive from a chemical equation. By the end of this lesson, you should be able to identify reactants and products in a chemical equation, their physical state and relative amounts, recognize if a chemical equation is unbalanced and know how to balance it, and determine the type of reaction occurring and the environmental condition needed to initiate the reaction based on the chemical equation. And so to start off, what is a chemical equation? Well, it is a summary of a chemical reaction. So here we have the photosynthesis reaction where we have carbon dioxide reacting with water to make glucose and oxygen. And so on the left side of the yield arrow or the equal sign in the equation, we have carbon dioxide and water, and on the product side, on the right side, we have glucose and oxygen. And so if we look, it's labeled, but the coefficients are the number of molecules or the number of moles of each species, and the little subscript here is the number of atoms. So this is 2 oxygen atoms, 2 hydrogen atoms, 6 carbon atoms, and so on and so forth. And we also have another subscript. This is the physical state. So G is for gas. This is carbon dioxide gas. L is for liquid, so this is water as a liquid. S is for solid, so it's solid glucose, and another gas. You may also see AQ, which stands for aqueous, which means dissolved in water. So you may also include an environmental condition necessary to initiate the reaction, which would be under the yield arrow. So for this one, it is light because it's the photosynthesis reaction. And chemical equations are essential to chemistry. Why? Because they help to convey the Dalton's law of conservation of mass, where atoms are neither created nor destroyed. And so the amount of starting materials will be the exact same as the amount of ending materials, just rearranged. And balanced chemical equations are also useful in stoichiometric calculations, so trying to determine how much of a product will be made from a certain amount of reactants or how much of a reactant you will need to make a product. And here we have a little diagram of stoichiometric calculations, and this mole-to-mole ratio comes from balanced equations. So let's balance an equation. Here we have the combustion reaction between methane and oxygen, making carbon dioxide and water. And the environmental condition needed is heat. So let's count. We have 1 carbon atom on the left side, 1 carbon atom on the right side, 4 hydrogen atoms on the left side, but only 2 on the right. And we have 2 oxygen atoms on the left side, but only 3 on the right. So what can we do? We can add coefficients. So let's start with the hydrogen. If we added 2 in front of the water molecule on the right side, this makes 4 hydrogen atoms because there are now 2 molecules, and each molecule has 2 hydrogen atoms, and 2 plus 2 is 4. So now the hydrogens are balanced, so let's balance the oxygens. There's 2 on the left side, but now there's 4 on the right side. So if we add a 2 to the left side, we now have 4 on the left side and 4 on the right side. We can also use chemical equations to determine what type of reaction is occurring. So we can have a synthesis reaction or a decomposition reaction or a single displacement or a double displacement where the chemical species are kind of just being shifted around. And a chemical equation is like a recipe. So let's make some burgers. We need ground beef, buns, and heat to make a hamburger. But if we look, this equation is unbalanced because our ingredients require 2 buns. So what can we do? That's right, add a coefficient. And so now we see that this is a balanced equation. Can anyone tell me what type of reaction it is? If you said it was a synthesis reaction, you are correct because we have 2 things coming to make 1. And a real-life example of how a chemical equation can be useful is the ocean acidification equation. So we have carbon dioxide reacting with water and carbonate ions to make carbonic acid. And this acid lowers the pH of the ocean, making it unsuitable for most life. And this reaction also removes carbonate ions from the ocean, which are necessary for the calcium carbonate shells of some marine organisms. So they're taking the building blocks out from the ocean that make the shells of marine life, and without a shell, they are not likely to survive. And so, did you learn how to read a chemical equation and identify quantities and physical states for reactants and products, environmental conditions needed to initiate the reaction, and the type of reaction it may be, how to balance a chemical equation, how a chemical equation is like a recipe for your favorite dish, and a real-life example of a chemical equation that can be written as, of a chemical reaction that can be written as a chemical equation? If you did, thank you so much for watching. Here are the resources, and if you didn't, go ahead and watch this video over again. And thank you so much. Have a great day.